Okay, we're going to look at integration by substitution. This is the most used and most abused technique of integration, so you really want to make sure you have it down. When facing an integral problem, first you should always simplify algebraically. That should always be the first thing you do. The second thing, after you've simplified, is there a straight or easy antiderivative that you recognize? Right, so is it the power rule? Is it a trig function? Something that you know the antiderivative of. So those are your first go-to. And then the third, which is the one that we're looking at here, is by substitution. All right? So the goal is, when somebody is first learning how to do integration by substitution, they always ask, what is that exactly do you substitute with what? Well, one thing to know is sometimes you're going to be wrong. And that's okay. You just erase, scratch out, or whatever, and you start again. So that's okay. And the second thing is just try something, right? So just try something. Don't just panic or I don't know how to do it. Okay, but your overall goal is that you're looking at pieces of the function so that you see a function whose derivative is also in the expression. All right, so you're wanting to make a substitution on the function, in this case, the way I've written it, I'm going to say u for g of x, because you see the derivative in the expression. So that's kind of the overlying principle that you want to try. So let's look at a couple of examples and see how that goes. Okay, so in this case, I see a lot here, and so I would say, first, you want to simplify. And some will want to multiply this out and then apply the product power rule 3 times, and that's fine. But it isn't necessary in this case because there is a quick and easy substitution. So usually you substitute the harder or the more complicated function. And so if I were to do that, I would my temptation is to call this right here my u, for my u substitution. So I come over here and I say, well, let's let u be equal to x squared plus x. This means du is equal to 2x plus 1 dx. All right, so I have to replace all my x's with the appropriate u's. So I look over here and I see this 4x plus 2, which is almost the 2x plus 1. But if I do some factoring, so if I take this one and I factor out a 2 first, so now I have 2x plus 1, and then x squared plus x dx. I know the 2 can come out in front of the integral, right? So 2, and let me even rewrite this in the other order. X squared plus x, and then 2x plus 1 dx. Okay, at this point, I see there's my u, and this whole expression is my du. Right, so this is 2u du. And so now we don't even have x anymore. And now this is the straight power rule. This is equal to 2u squared over 2 plus a constant c. Those 2's cancel, so it's just u squared plus c. But we always, if we can, go back and write our expression in terms of the original variable. So u squared is really x squared plus x squared plus c. All right? Let's look at another example. This one's a trig one. And in later videos, we'll look at lots of trig integrals. But you should always, so we know the relationship between, in terms of derivatives of sine and cosine, right? So the derivative of sine is cosine x, and the derivative of cosine x is negative sine. Okay, so if I see sines and cosines in my expression, then a u substitution is the first thing I think about. Although it's not always going to work, as you'll see later. But in this case, it does. So we might say, do I have a choice? Can I let u be sine or u be cosine? But the truth is no, or that isn't the best substitution, because let's say you do. Let's do it incorrectly and see how it won't break, and we can keep going. If I say let u be equal to cosine of x, then du is, as we saw, negative sine x dx. Sorry, that is the one we want to do. So let's do the wrong one first. So if I say let u be equal to sine x, then du is cosine of x dx, right? I can replace this with u, the sine x, with u, and one of the cosine x's with, so I could rewrite this. Let's write it in this order. Sine x, and then cosine x squared is really cosine x times cosine x dx. So there's my u, and there's my du, but I have this extra floating cosine of x. So I don't like this substitution. All right, so instead, let's try this again, and we'll switch colors. We're going to let u be equal to cosine of x. Du is negative sine x dx. And we're never worried about a negative that appears that isn't in the original, because I can fix that. I can always fix a constant. All right, so then this expression can become u squared. If I put a negative, so let me just show you how we fix that. If I can write this as negative cosine squared x times negative sine x dx, right? Because that's two negatives, which really is just the positive. So that's a way to rewrite a positive into two negatives. All right, so there I see my du, and there is my u squared. All right, so then this becomes minus u squared du. Now, I'm going to anti-differentiate this, so this is negative u cubed over 3 plus c. And as I said earlier, we always go back to our original function, our original variable, which is, what did we call u? Cosine of x. So our final answer should be negative cosine of x cubed over 3 plus c. Okay, one more. And this one's actually kind of a tricky one that I like to call the inside out method. And so as you see here, I can't simplify this in any simple way, which is going to be the first thing I check. I don't recognize this expression as something that has a nice antiderivative, or nice, easy antiderivative. So my next technique that I'm going to try is substitution. I don't see an obvious substitution. In fact, usually I let something be a squared, and then the du is the x. But if I'm crafty, I might see some interesting things. So after you do a lot, you'll probably have a gut feeling, and you want to make the more complicated things more simple. So your gut may tell you to let your u be equal to 2x minus 1. Well, then your du is 2 dx, which, remember, a constant's always okay. I can always put a 2 inside as long as I take out a half. All right, so then I really just put a 1 in there. Well, so what does that become? Then we have 1/2 x over the square root of u du. And as we saw in that earlier problem, we have this floating x right here. But changing my u to something else doesn't seem like that's going to work like it did in the last problem. But all we really need to do is make sure everything is in terms of u. So look right here. Since I let u be equal to 2x minus 1, I can solve for x, and that is u plus 1 over 2 equals x. I just solved for x in terms of u. Okay, well then that means this expression is 1/2. What is my x? U plus 1 over 2, all divided by the square root of u du. All right, I'm going to pull that 1/2 out. So now I have 1/4 u plus 1, and instead of writing the square root of u, I'm going to write u to the 1/2 du. Now you might think, well, that doesn't look any better than the thing I started with, but this is why I call this the inside out. I can't simplify that x inside of this radical, but I can take this radical and divide it into each one of those pieces. So what this really becomes is, well, I'm going to split it up. U over u to the 1/2 u over u to the 1/2 plus 1 over u to the 1/2 du. Let me get that out of there, so it's kind of distracting. All right, so let's simplify still. I'm not ready to take the antiderivative because I'm using my simplify first rule. So this is 1/4 u over u to the 1/2. So that's really to the power of 1. You subtract exponents, so it becomes u to the 1/2 on top, plus, and that 1 over u to the 1/2 is u to the negative 1/2, all of that du. So now I just do the power rule. So I have a 1/4 u to the 3/2 over 3/2 plus u to the 1/2 over 1/2. All of that plus c. Let's clean this up a little bit. So that's really, I'm going to distribute that 1/4 and flip my fractions. So that's really 2/3 times a 1/4 u to the 3/2 plus a 1/4 times 2 u to the 1/2 plus c. All right, so that really is 1/6. I'm going to now replace my u's with what I called them, which was 2x minus 1. So 1/6 2x, I'm sorry, what did I say? 2x minus 1 to the 3/2 plus 1/2 2x minus 1 to the 1/2 plus c. That's it. Excellent. If you want online tutoring with me via Skype, check me out at www.elizabethstepp.com/tutoring.